Welcome to all. Myself, Professor Deshmukh MS, presenting the theory lectures based on the gas lubrication. So, what exactly the gas lubrication is there? The gas lubrication is simply that, as the name suggests, the gas used as a lubricant in the lubrication, that is called gas lubrication. So, what is the first kind of lubrication? That lubrication is nothing but what? It is the process of inserting or adding the lubricant between the two parts, or the substance adding between the two parts in order to reduce the friction and wear. That is called the lubrication. What happens in the case of the gas lubrication? There is a the state of substance is gaseous, not the liquid. So in that case, we are using the nitrogen and oxygen or any gases which is suitable for the lubrication purpose, depending upon the applications that can be used for the lubrication purpose. The gases having the different properties to compared to the pure liquid substances. So we will see the gas lubrication in detail. Let's see the introductory parts of the gas lubrication. The friction and wear, a tribological phenomena that everybody knows that, which has a significant economic damage and environmental issues throughout our history. The mechanical and thermal severities caused by the friction, along with the consequent wear, are some of the most relevant problems faced by engineers in the machine design. So, it's a different kind of lubricant and coatings are solutions for the currently to reduce the friction and to avoid the presence of the wear. So, that the case of this, the performance is based on the gas lubricant makes it possible to significant reduce with the high positions. Okay, so gas lubricants are employed in a high precision applications such as medical equipment and measuring tools. Now something beginning of this, that we are having the Daniel Bernoulli's equations was being found with some lubrications as a fluid. So the result of this total the adverse experiment was formulated study to discuss the fluid flowing under the laminar regimes. Okay, so delta P is equal to 128 mu LQ upon pi d raised to 4. These equations made it possible and assess the pressure drop within the laminar flow through these pipes. He found the pressure drop delta P. So delta P that we are find out that 128 mu LQ upon pi d raised to 4, where delta P is the state capillary increase pressure drop, which will be along with the state capillary increases proportionally to the tube length L, fluid mass flow rate Q, and viscosity mu, and it decreases with the fourth power of conduit diameter. Mu is equal to viscosity, L with the length, up to Q is equal to fluid flow D conduit diameter. Okay, now look at this diagram. This diagram shows the different pulleys. Okay, so I am some weight which is attached to it, that hinge experiment apparatus for frictional measurement. Now frictional measurement means what? It having some effect of the lubricant, that tube is being separated by the fluid film. Okay, so what should be the lubricant about the gas lubricant? For water and air to act as a lubricant, it is necessary for a drum to turn sufficiently rapidly to drag them into the bearing when the speed of reduces to the certain values and the two non-viscous surfaces come into the direct contact, the friction at once become the enormous. So this is the case again. Now look at the formula. For Petrov formula to correlate with the friction force and that of the bearing parts parameter, that is Fw is equal to mu ua upon eta and mu upon lambda 1 plus mu upon lambda 2, where eta and mu are film thickness and the viscosity. Okay, film thickness and that of a viscosity. U is a tangential relatively velocity between the two interacting surfaces. A is a contact area, that lambda 1 and lambda 2 is a coefficients with considerable slip phenomena at walls for interacting the surfaces, despite much effort devoted to the performing studies on hydrodynamic lubrications. Petrov equation was not able to find the relations that exist between the friction and the load carrying capacity. Now look at this diagram. Diagram shows that bearing with hole on the top and bearing with axial grooves. Now this will be shows that the gases will be interrupt the areas which will be with the bearing at the top of your shaft. Okay, either it is at the top or either it is at the grooves. This will be the tower experimental bearings. It shows the gases effect over these conditions. So this is all about the case.